Well, I am just about wrapped up on this project here, this old Axelson lathe, and I've got it really well tooled, looking good, running good, at a grand total of about $8,500 is what this cost. And it is, I suppose, without a lot of the extra tooling, like if you're buying a new lathe, you get a couple of chucks and maybe a tool poster, a couple of wrenches, maybe right about there, about $6,500 would be the equivalent, you know, of this machine, looking like it does, running like it does, with just a couple of chucks, about 6,500. But I got it about 8,500, smartly tooled, and with a Trav A Dial. So, kind of what would be a typical lathe in the 1980s, 1990s, I guess. I don't know. The quality of this machine is just outstanding. I can't really believe the quality of it. It's just amazing. The only problem with these older machines compared to newer machines, newer designs, like the Hercules Ajax, the Mazak, is the small spindle holes and that just kind of the heavy nature of parts of them that make them a little bit slower to use. Shifting's kind of hard on this machine. The headstock's real tight on it, but I think you can see my feet come off the ground sometimes shifting this old lathe, which is really kind of a kick in the pants. It's good for me. I need the exercise. But let's have a quick look at it. I'll show you some of the details. It's just kind of neat to wrap this up. Yep, with the Trav A Dial's the last thing that's going on there. See, it'll be just like that. Kind of tucked in here like that. Oh, what a nice deal. But one of the funny things about this machine is this tailstock, and a crank for it was optional. And so this one didn't have it. And so I got to get behind it and push it. But it's got this incredible long quill travel that it really doesn't have much wear. There's not any problem with the tailstock because it didn't get moved very much in the first place. Now, I should probably move the tripod over here. I've been using this chuck, and now this is the one I ground the jaws on. Let me tighten that up, see if this thing will fall down. Yeah, this is the one I ground the jaws on, and it's just kind of checking it out. I made a couple of parts on it, just been using it a little bit. Way at the end here, it's about 7 inches out. It's got, what is that? 1.5 thousandths run out. So that's real good. Let's move it in. See where we're at here. Okay, it's 1/2 thousandths there, but it doesn't always repeat that good. Now remember, this is a chuck that I did not totally rebuild. Like that 6 jaw. Okay, but I will eventually rebuild this if I use it enough. How are we doing? See, that's more typical, about 1.5 thousandths there. How this thing's repeating, and I think that's pretty good for an old chuck like this. This chuck hasn't been used an extreme amount, but I estimate that it's 60 years old. Yeah, that's the more typical I've been getting out of it is 1.5 thousandths, which is really acceptable. Let's move it out. See what it's doing out here. I've got this to go about as much as 4 thousandths out. Way at the end, which is still pretty good. That's 3 thousandths. Yeah, right there. So let's just keep making parts on this thing, and you can touch, after initially grinding the jaws in, touching them up takes 20 minutes. Okay. What have we got here? Right at 1.5 thou. See, that seems to be where it wants to be. Let's see what it's doing back here. Whoop, that didn't work. Let's get that back down there. Oh, I did it again. There we go. Yeah, it's running 1 thousandth. So 1 thou and a half is really pretty nice on a chuck, you know. And when they start getting about 3, I start getting irritated at them. So I'll run this like this for quite some time. So I think that's just plain good. Now I still have that 12-inch chuck to do, and I expect really good results out of it because it's extremely tight on the inside. Okay, so what a project this has been. And it's really quite useful. Quite useful. Handy machine. Here, I gotta have a drink of water here. So, I just using the machine, I'm kind of getting used to the old gearhead lathes again. The last one I had was quite a bit bigger and more powerful than this. Heavier machine is a bigger launch and Shipley power term. Now, one of the things I did here, it was missing this thumb screw here. So I made this little thumb screw, and I will make another one because I need some for the cutter grinder, and show you some ins and outs of making a small part like that. Let me unscrew this. On a big old machine. Yeah, see that? That's kind of fun. You know, I can't keep track of the hours I have in this machine. And I put pictures of it sitting on the skid, how it came when it was shipped to me. And you see a lot of machines looking like this. This one here was kind of heavily contaminated with the old Tap Magic fluids and really sour thread cutting oil in the sump. And what they do here at the government installations and stuff is they bury the machine. They just, they have a big pit in the ground. They just drop them in rather than clean them up. So this one here was in private industry, so it, luckily it wasn't disposed of that way. It was sold contaminated as it was. But I'm glad, I'm glad it was. And this is, I guess, typical. This is something that Yoder sold as is. They usually clean machines up, but this one, they threw it on eBay. But I think this Axelson's kind of typical, which you'd find at HGR, And if you're looking at old machines like this, the initial price was $3,200. Then there was shipping, and that brought it to $5,000. And that was a couple years ago. I don't know what shipping is now. So you see the $3,000 lathe on HGR or something, and you got the shipping and then fixing it up like I did here. So I thought I'd just kind of clue you in on what the actual cost of this thing is. And I think it's well worth it. I think about $8,500 is pretty good. It's I just got a monstrous amount of tooling over there, concentrated on those shelves, and it's just a great deal. Okay, I think I'll do a video of making a small screw on this, and I'll show you the tooling I use and the pitfalls of making small parts on a larger lathe. Okay, I'll be back. Well, I'm putting together a bracket here for the Trav A Dial, and I'm going to bend it like that, and I marked it, kind of trim that corner a little bit, and I got to mark it down here to clear this bracket right here. I move that up. Not very much, just a little nick there. Okay. Oh, look at a Trav A Dial. Now, I looked on eBay, and these things go for a lot of money now. And the reason they do is because they're extremely easy to use and very useful. It's got a tapered wheel here. I've talked about this a little bit, but I'm going to put this on now on this machine. And when you move the wheel, see the dial moves. And this dial here, when it's up against the lathe, you can move it without moving the needle. So you can set that on 0. Then you can rotate this bezel here and set it on 0 too. And it's just the simplest thing, but it's very easy to use. And I find it easier to use for me than a digital readout. But these things can, there's a brand new one. I don't know when they quit making them, but there's a brand new one for $1,800 on eBay. But I think the average price for one that looks reasonable is about $500. Now, this won't do you a whole lot of good. I want to point that out about these. You need this pile of junk to mount it. And this is the base that the Trav A Dial goes into. And it's adjustable. And it's and it flexes. I moved this before. It's got this, all these springs here on the ends and this 2-piece deal. And there's quite a method to set this thing up. So the Trav A Dial slides into the dovetail like that. But then there's a way to load this. And that's with this little metal yoke and this little block with a set screw in it. Then there's all these other pieces There's conical washers and a couple of 1/4-inch fine thread bolts. Here's the conical washer thing. If you don't have this, you have to make it. You see, here's a little beveled washer and a steel cup like that. See, you got to be able to tilt this thing on its bracket. And that's how it works, because this wheel is, the face of it is tapered. So as you tilt this thing, that's how you zero it, using like a micrometer standard against your carriage stop. And you keep running it back and forth and adjusting the tilt on it until you get it zeroed. So that's what I'm doing with this. And I thought, hey, it might be worth a video basically talking about maybe a video or two, because it's a little bit complicated hooking this up. But these are still around. I was really kind of surprised especially at the prices. But then you look at the usability of the thing. Okay, well, I'm going to set that there. Got a bunch of stuff going. I'm kind of buttoning up the situation on this. Okay, well, I'm going to stand up here and kind of put this away so I don't knock this expensive Trav A Dial on the floor. Okay, I'll be back in a minute here. Now that I've pretty much got that Axelson Lathe project wrapped up, I can focus more attention on this drill press here. And a couple of things bad happens to these things if they sit in the weather. This spline drives the head, and that got rusted into this gear in here, and that was extremely difficult to get that loose. And of course the bearings that this head actually rides on are just ball bearings, 2 of them, that ride on this track here. And I'm not sure what happened, but if those bearings, you don't want any chips to get in here, and that could have been what happened, because what happens, it lifts up and it wedges the head. This is how the head locks here. But anyway, this is loose. I had to take a torch and burn those bearings out deep inside there. And it'll move now. See, it'll move. But it's running on the lock. This is the actual lock here. It should run on those bearings. And then you tighten the lock, and it pushes down and lifts the entire head up and locks it on this angle. And so, it makes sense, because as you're drilling, it's pushing the head up into that. So I got to remove this head, like take it off. And they had an emergency measure. Now, this is the identical drill press to the one on the Battleship, New Jersey. And I'm not sure of the special purpose of these drill presses, but they have a window here, but it's dead-ended, and it's in the exact right place. If you bore on through into this area here, but back there, then you can get to those bearings. And I think I'll take the head off. So I got to take this bracket off, slide that head off. This drill press weighs 6,000 pounds. And I expect that head weighs, I don't know, 1,500 anyway, pounds. It's full of gears. It's big. These Morris drill presses, kind of on the smaller size, have an oversized head. You know, that's if you look at a 9-inch column, a 3-foot arm drill press, that head is huge. Just really a slick old machine, the old design like this. So I'm going to go ahead and pull the machine back out a foot. I had to move it to get that Axelson around this corner. That was a traffic jam. So anyway, I'm going to move this thing out. You have to be extremely careful moving these radial drill presses. I have to chain the arm down, because if you move this thing and it starts rocking and the arm swings out, it'll surely fall over. I can't keep track of the hours on this thing. It's in the hundreds now. And I didn't really keep track on that Axelson, but I would imagine it's a couple hundred hours on that too. Okay, you guys have a great day, and I'm just going to keep plugging along. Take Chloe out for a walk. It's pretty nice this morning. Okay, bye.